Hello children, today we continue with our chapter 2 measurement, and we have already discussed about measurement of length and measurement of mass. Now we are coming to a term called the speed. You all have a pretty fair idea about speed because you have learned it in your previous class also. So I just want to ask you a simple question. Does a bullock cart run faster or a bullet train? You have the answer in your mind, isn't it? Now, you might be thinking, what a question is this? Everybody knows a bullet train has a greater speed than a bullock cart. So why do you think that a bullet train has a greater speed? Because when you think of speed, you have to consider two things. One is that how much distance it has covered. Okay, how much distance and in how much time. So whenever you think about speed, we think about two things, how much distance and how much time. You understand that greater the distance covered, okay, and shorter the time is, you say it is a greater speed, okay. So that is, so I hope you understood that greater the speed, shorter the time, then we say that the speed is greater. Okay, so where there is a formula given for finding out the speed. Speed is equal to distance traveled by time. Okay, so you know that distance traveled is in the numerator. Means more is the distance traveled, more will be the speed. While time is in the denominator. So more is the time taken, less will be the speed. But less will be the time taken, more will be the speed. So that is the formula for speed. Now we come to another term, uniform motion. Okay, so when the word uniform comes means same, something which is same. So let us see the definition of uniform motion. If a body travels equal distances in equal interval of time, its motion is said to be uniform. So the things that take place at the same pace, that is they are covering equal distances in equal interval of time, then we say that the motion is said to be uniform. Okay, like the motion of the earth around the sun, so there is a uniformity that it travels, so that we can say that 1 year will be completed in 365 days, or one day is 24 hours, because the revolution of the sun, revolution of the earth, okay, and rotation of the earth, that is all at a uniform speed. Now let us consider an example here. You see a car here. Now see, look at this. At 0 meter, at 0 second, the what is the distance of the car? 0 meter. So it was here. After 2 seconds, the car changed its position to 4 meters. So this was the position of the car at 2 second time. And after 2 more seconds, that is total 4 seconds, the car is at a position 8 meter from the start point. So it has come 8 meter. Then after 2 more seconds, now it is a distance of 12 kilometer. So think whether its motion is uniform or non-uniform. So let us think. In every 2 seconds, how much distance it is moving? In this first 2 seconds, it is moved how much? 0 to 4. So that means it is 4 meter. In the next 2 seconds, it goes from 4 to 8. So how much is that? 8 minus 4, that is again 4 meter. And in the last 2 seconds, it goes 12 from 8. So we will say how much distance has it traveled? 12 minus 8. So that is again 4. So it is going in every 2 seconds, it is going 4 meter. 4 meter, 4 meter, 4 meter. So that means it is uniform motion. So if we want to plot a graph for this, let us just see if we want to plot a graph, how will it be? We will say time and distance. At 0 time, distance is 0. In first 2 seconds, the distance is 4 meter. In 4 seconds, distance is 8 meter. In 6 seconds, the distance is 12 meter. Okay, so this is how we can plot, we can write the values in a graph. Okay, that how is it, whether you can say look at the graph and tell whether it is uniform motion or non-uniform motion. So you have studied about uniform motion. Now, so what will be non-uniform motion? When the body is not maintaining any equal distance, it is just going as it likes. Okay, that is non-uniform motion. So we'll just see the definition of non-uniform motion. What is the definition? If a body travels unequal distances in equal interval of time. So that means after every second it goes unequal distances. Like if you are moving through a very busy street, okay, in a car you are going on a very busy street, can you maintain an equal uniform motion there? You will be increasing your speed. Suddenly when somebody comes in front of you, what will happen? You will suddenly brake, isn't it? So you will keep on changing the speed, accelerate or apply the brakes. So like that, the motion becomes non-uniform. Okay, so let us just see an example for non-uniform motion here. Again, our car is going now. First you see the initial position was 0 meter at 0 second. After 2 seconds, it travels 1 meter. The next 2 seconds it is traveling, it has come from 1 meter to 10 meter. Then in the next 2 seconds it is reaching 25 meter. So let us just look closely and analyze how much distance is traveled in every 2 seconds. So first 2 seconds you see it is traveling 1 meter. In the next 2 seconds from 1 meter point it has come to 10 meters. So that means total 9 meters. So how will you find the distance? 10 final minus initial, you see 10 minus 1. So that is traveling 9 meter in 2 seconds. And then next 2 seconds it has come from 10 meter to 25 meter. That means it has traveled how much? 25 minus 10. So that is 15 meter. So here 1 meter, then 9 meter, then 15 meter. In the same time, same interval of time. Here it is written equal interval. So what is the equal interval of time? 2 seconds. 2 seconds, slowly it started. Then after 2 seconds, it gains speed. So it is going faster. Now it is covering 19 meter in 2 seconds. Then in the next 2 seconds, it's traveling 15. It is going faster, isn't it? So we graph it and we see how it will be in a graph. Okay. So here I have shown you time 0 seconds, 0 meter. Time 2 seconds, it has reached 1 meter. In 4 seconds, it has reached 10 meter. In 6 seconds, it has reached 25 meter. Okay. So that means this motion is what? Non-uniform motion. Then we come to another new term that is called average speed. Okay, average speed. So when you say you are coming from one city to another city, if you say your speed has been 80 kilometer or maybe 70 kilometer per hour, you must have heard people saying, no, you can travel at 40 kilometer per hour or 60 kilometer per hour. So what does that mean? That doesn't mean that at every time, every instant of time, the car was running at this speed. We just calculate the average speed, and the speedometer, no, it measures the speed at a particular moment. But when we say it, we say an average value. Okay, so average speed was 60 kilometer. So how is average speed calculated? Let us see how is average speed calculated. The average speed is calculated by finding the ratio of the total distance traveled by the body to the total time taken in the journey. So you have to divide the total distance by total time. Whenever it is written ratio, that means you should understand that one quantity is divided by the other quantity. So here what we are dividing the total distance by the total time. Okay. So let us see here the formula: average speed is equal to total distance traveled by total time taken. Now you know the how to find the speed. Speed is distance upon time. So what will be time? How will you calculate time? Time can be calculated by using the formula distance by speed. And how will you calculate distance? distance is speed into time. So these are the three formula that you can use while solving the numerical problems related to average speed. Okay, so when I talked about numerical, I would like to show you one numerical problem also. Here's the problem. A car travels 100 kilometer with a speed of 50 kilometer per hour and another 200 kilometer with a speed of 20 kilometer per hour. Okay, so first it was going at a good speed 50 kilometer per hour, and then suddenly maybe the roads were very bad, so it was going at a very slow speed, that is 20 kilometer per hour. So you see, first distance is 100 kilometer and the next is 200 kilometer. So is the motion uniform? Can you say the car was moving with a uniform motion? No, because it is changing its speed. So when there is a change in speed, we will say it is non-uniform. Okay. Then find the average speed of the car. So our answer is, first answer is, the speed of the car is not uniform. Okay, it is non-uniform. And then second answer, let us consider, now we don't know the time taken. When we want to calculate average speed, we know that we should know the total distance and total time. Okay, now here time is not given, but the distance and the speed is given. So we will use the formula for finding out the time for the first part. We will divide it into two parts. So first part, time taken for the first part of the journey is equal to distance traveled by speed. So what is the distance traveled? 100 and speed is 50. So 100 by 50 is 2 hours. Clear? Now we come to the second part of the journey. We have to take the time taken for the second part of the journey. It is distance traveled by speed again. So you see here distance traveled is 200 and speed is 20. So 200 by 20, that is 10 hour. So what is the total time for the journey? 10 hour plus 2 hours, isn't it? So we get 12 hour. Okay. Now let us see total distance. What is the total distance? So 100 kilometer first and then 200 kilometer. So 100 plus 200 is 300 kilometer. So that is the total distance. Now we are ready with the total time also and total distance also. Now we can use the formula for average speed. Average speed is equal to total distance by total time. So 300 by 12 and we get 25 kilometer per hour. So this was a little difficult sum which I have done for you. Now there are many easy sums, numerical problems which are waiting for you. So I hope you will be able to do all the problems today itself. Try today, use the formula. So what are the formula that you are going to use? One is for the speed, distance traveled by time taken. Next is for the time taken, you can use the formula distance by speed, and for the distance you will use the formula speed into time. So these are the three formulas, and for average speed you can use total distance by total time. So all the best. Try all the numerical problems that are given at the end of the chapter.